Hello, let's get started. Let me share my screen. And I hope we can start. Once again, hello everyone, and welcome back to the channel. If you are interested in data engineering, analytics, or Microsoft Fabric, you are in the right place. In today's video, we are going to explore one of the most powerful technologies available in the data world, Apache Spark, and more specifically, how you can use Apache Spark within Microsoft Fabric. Whether you are new to Spark or already have some experience with it, this video will help you understand how Spark fits into the Fabric ecosystem and how it can be used to build scalable data solutions. So let's get started. First, what exactly is Apache Spark? Apache Spark is an open source distributed data processing framework that is designed to handle large-scale data processing and analytics workloads. It enables organizations to process massive amounts of data efficiently by distributing the work across multiple computing resources and executing tasks in parallel. Because of its speed, scalability, and flexibility, Spark has become one of the most popular technologies for big data analytics. Today, it's supported across multiple platforms, including Azure HD Insight, Azure Synapse Analytics, and Microsoft Fabric. In this video, we'll focus on how Spark is integrated into Microsoft Fabric and how it can be used to ingest, transform, process, and analyze data within a lakehouse environment. One of the great things about Spark is that the core concepts, APIs, and coding techniques remain largely consistent across different platforms. So the skills you learn here can often be applied in other Spark environments as well. One of the great things about Spark is that the core concepts, APIs, and coding techniques remain largely consistent across different platforms. So your skills, sorry, I'm okay. However, Microsoft Fabric takes the experience a step further by providing a unified analytics platform where Spark works seamlessly alongside other Fabric experiences, such as data engineering, data factory, data warehouse, real-time analytics, and Power BI, of course. And this integrated approach eliminates many of the complexities involved in managing separate services and makes it much easier to incorporate Spark-based processing into your end-to-end analytical solutions. So throughout this just a video, we'll look at how Spark notebooks work in Fabric, how data is processed in a lakehouse, and how Spark can help you drive valuable insights from large data sets efficiently and at scale. So sit back, follow along, and let's dive into Apache Spark in Microsoft, Fabric, right? So let's go on with our, second slide where okay, we are going to also talk about Apache, Spark. So now that we have a basic understanding of Apache Spark, let's take a closer look at how it actually, works. And at its core, Apache Spark is a distributed data processing framework. That means it can process massive amounts of data by spreading the workload across multiple machines that work together as a cluster. So in Microsoft Fabric, this cluster is known as a Spark pool, right? The easiest way to think about Spark is through the concept of divide and conquer. Instead of a single computer trying to process an enormous data set on its own, Spark breaks the job into smaller tasks, distributes those tasks across multiple nodes, and then combines the results for you. This parallel processing approach dramatically improves performance and allows organizations to analyze large-scale datasets much faster. The good news is that Spark handles all of the complexity behind the scenes. You don't need to manually distribute the work or collect the results. Spark takes care of that automatically, allowing you to focus on solving business problems rather than managing infrastructure. Another reason Spark is so popular is its flexibility. It supports multiple programming languages, including Java, Scala, R, SQL, and Python, of course. This allows developers and data professionals to work in the language they are most comfortable with. However, in modern data engineering and analytics projects, the most common approach is to use a combination of PySpark and Spark SQL. PySpark gives you the power and simplicity of Python for data transformation and analysis, while Spark SQL makes it easy to query and manipulate data using familiar SQL syntax. As we move through this video, you'll see both of these technologies in action and learn how they can help you efficiently process and analyze data within Microsoft Fabric. One of the great advantages of Fabric is that it makes getting started with Spark incredibly easy. Every Fabric workspace comes with a built-in starter just pull, right? And okay, and this allows you to begin running Spark notebooks and jobs almost immediately without spending time provisioning or configuring clusters. It's a great option for development, learning, and many day-to-day data engineering workloads. The starter pool isn't completely fixed, though. You can customize its configuration to better align with your performance requirements, workload characteristics, or cost considerations. For organizations with more specific needs, Microsoft Fabric also allows you to create custom Spark pools. These pools give you greater control over the compute resources used by your Spark workloads, enabling you to tailor the environment for different use cases and teams. You can manage the starter pool and create additional Spark pools from the admin portal. Within your workspace settings, navigate to capacity settings and then select data engineering and data science settings. When configuring a Spark pool, there are several important settings to consider. First, there is the node family, which determines the type of virtual machines and used by the cluster. In most scenarios, memory optimized nodes provide the best performance for data engineering and analytics workloads. Next is autoscale. This feature allows Fabric to automatically add or remove nodes based on workload demand. You can define the initial number of nodes and the maximum number of nodes that the pool is allowed to scale to. Another important setting is dynamic allocation. Instead of statistically assigning executors, Fabric can dynamically allocate executor process based on the amount of data being processed. And this helps improve resource utilization and optimize performance. If you have multiple Spark pools in a workspace, you can also designate one of them as the default pool. Whenever a notebook or Spark job doesn't explicitly specify a pool, Fabric will automatically use the default one. Overall, Spark pools provide the scalable compute foundation for running data engineering, data science, and analytics workloads within Microsoft Fabric. So far, we have focused on the compute layer that powers Spark workloads in Fabric. But compute resources are only one part of the story. To ensure consistency, compatibility, and the right set of libraries for your workloads, Fabric also provides Spark runtimes and environments. In the next slide, let's explore how runtimes and environments work and why they are important when developing Spark solutions in Microsoft Fabric. Now that we have looked at Spark pools, let's talk about another important concept in the Spark ecosystem, environments. When working with Apache Spark, the software that's installed and used behind the scenes is determined by something called a runtime. The Spark runtime includes the core components required to execute Spark workloads, such as the Apache Spark version itself, the Python version, Delta Lake support, and other essential dependencies. As the Spark ecosystem continues to evolve, multiple runtime versions become available, each offering different features, performance improvements, and compatibility options. Beyond the core runtime, Spark also gives us access to an extensive ecosystem of libraries. In fact, one of the biggest strengths of Spark um, is its ability to integrate with thousands of open source libraries that help with everything from data transformation and machine learning to advanced analytics and artificial intelligence. Since many Spark workloads are developed using PySpark, data engineers and data science can take advantage of the vast Python ecosystem. Whether you are working with Pandas, NumPy, scikit-learn, TensorFlow, or specialized industry-specific libraries, there is usually a library available to help solve the problem efficiently. In real-world organizations, however, not every project has the same requirements. One team may need a specific version of Python, another may require a particular machine learning package, while another might depend on specialized data processing libraries. That's where environments come in. An environment allows you to define a consistent and reusable Spark configuration. It specifies the runtime version that should be used, along with any additional libraries and dependencies required for a particular workload. Instead of manually installing packages every time a notebook is executed, teams can create standardized environments and reuse them across projects. This helps improve consistency, simplifies collaboration, and reduces dependency related issues. Data engineers and data scientists can then select the appropriate environment when running workloads on a Spark pool, ensuring they have exactly the tools and libraries needed for the task at hand. Think of an environment as a pre-configured toolbox. Different projects might require different tools, and environments allow you to quickly switch to the toolbox that's best suited for the job. So far, we have discussed what environments are and why they are important. But how does Microsoft manage Spark runtimes and what runtime options are available out of the box? In the next section, we'll take a closer look at Spark runtimes in Microsoft Fabric and see how they provide the foundation for building reliable and scalable Spark solution. As the Apache Spark ecosystem continues to evolve, new runtime versions are released with enhanced features, performance improvements, security updates, and support for newer libraries. To keep pace with these advancements, Microsoft Fabric supports multiple Spark runtimes and continues to add support for newer versions as they become available. Within your workspace settings, you can specify which Spark runtime should be used by the default environment whenever a Spark pool is started. This ensures consistency across notebooks and Spark jobs running within your workspace. But runtime selection is only part of the picture. Microsoft Fabric also provides a powerful feature called environments, which allow you to create customized Spark execution environments tailored to specific workloads. projects, or teams. Instead of using the same configuration for every workload, you can define environments with their own runtime versions, libraries, settings, and resources. When creating a custom environment, you have several configuration options available. First, you can select the specific Spark runtime version that the environment should use. You can also review the built-in libraries that Fabric automatically includes in every environment, helping you understand what's available out of the box. If additional functionality is needed, you can install public packages directly from the Python package index or PI, giving you access to thousands of open source Python libraries. For even more flexibility, you can upload and install your own custom libraries using package files. You can also associate a specific Spark pool with the environment, ensuring workloads run on the appropriate compute resources. Advanced users can define custom Spark configuration properties to modify default Spark behavior and optimize performance for specific scenarios. In addition, resource files such as configuration files, lookup data, or supporting assets can be uploaded and made available to notebooks and Spark jobs that use the environment. Once you have created one or more custom environments, you can designate one as the workspace's default environment, ensuring a consistent development experience across your Fabric workspace. Overall, environments provide a standardized and reusable way to manage dependencies, configurations, and runtime settings, making collaboration easier and helping teams build more reliable Spark solutions. So far, we have explored Spark pools, runtimes, and environments, which form the foundation of running Spark workloads in Microsoft Fabric. However, Fabric is also including several advanced configuration capabilities designed to improve performance, scalability, and operational efficiency. In the next slide, we'll explore some of these additional Spark configuration options, including the native execution engine, high concurrency mode, automatic ML flow logging, and Spark administration for a Fabric capacity. These features help organizations optimize Spark workloads and manage enterprise scale data platforms more effectively. So far, once again, we have explored Spark pools, runtimes, and environments, which are the primary tools for managing Spark workloads in Microsoft Fabric. However, Fabric also provides, as we mentioned a little bit earlier, advanced configuration options. So let's take a look at some of the most important ones. First starts with native execution engine. So this is a vectorized processing engine built into Microsoft Fabric that allows Spark operations to run directly on Lakehouse infrastructure. The result is significantly faster query performance, particularly when working with large datasets stored in Parquet or Delta Lake formats. Instead of relying solely on traditional Spark execution, the native execution engine optimizes how data is processed under the hood, helping reduce execution times and improve overall efficiency. The native execution engine can be enabled at the environment level by configuring specific Spark properties, or it can be enabled directly within an individual notebook or script when needed. For organizations working with large-scale analytical workloads, this feature can provide substantial performance benefits with minimal configuration effort. Second one is high concurrency mode. Let's talk about high concurrency mode. Whenever you run a notebook or Spark job, Fabric creates a Spark session to execute that workload. Normally, individual notebooks may use separate Spark sessions, but high concurrency mode allows multiple users and processes to share Spark sessions more efficiently. This improves resource utilization and can help reduce startup times and overall compute consumption. What's really impressive is that Microsoft Fabric maintains isolation between users and notebooks. Even though resources are shared, variables and code running in one notebook won't interfere with another user's notebook. High concurrency mode can also be applied to Spark jobs, making it valuable for both interactive development and automated production workloads. You can enable this feature from the data engineering and data science settings within your workspace configuration. Another useful capability is automatic ML flow logging. For those working in machine learning and data science, MLflow is a popular open source framework used for experiment tracking, model management, and deployment. In Microsoft Fabric, MLflow integration is enabled by default. This means that machine learning experiments, model training activities, and related data can be automatically logged without requiring developers or data scientists to write additional tracking code. As a result, teams can monitor experiments more easily, improve reproducibility, and maintain better governance over machine learning projects. If needed, this automatic logging behavior can be disabled through workspace settings. Finally, let's look at Spark administration at the Fabric capacity level. While many Spark settings can be configured with individual workspaces, administrators also have the ability to manage Spark settings centrally at the Fabric capacity level. This allows organizations to enforce governance standards, control resource usage, override workspace level configurations, and ensure consistent Spark behavior across multiple teams and business units. For enterprise environments, this centralized management capability helps balance flexibility for developers with control and compliance requirements for administrators. To summarize, these advanced Spark configuration options provide additional ways to optimize your Spark workloads in Microsoft Fabric. Native execution engine for faster query performance, high concurrency mode for improved resource efficiency and shared sessions, automatic ML flow logging for simplified machine learning experiment tracking, capacity level administration for centralized governance and control. Together, these features help organizations maximize performance, improve scalability, and streamline both data engineering and data science workloads within Microsoft Fabric. We have now covered the key configuration options available in Microsoft Fabric, um, from Spark pools and environments to advanced capabilities like the native execution engine, high concurrency mode, and automatic ML flow logging. While these settings help optimize how Spark runs behind the scenes, the real value comes when we start using Spark to process data. At the end of the day, regardless of the runtime, environment, or configuration you choose, your goal is to write and execute Spark code that can ingest, transform, analyze, and manage data efficiently at scale. So now that we understand how Spark is configured in Microsoft Fabric, let's move on to the next slide and see how to run Spark code. I will take a couple seconds of break. Sorry for this. Okay, sorry. Microsoft Fabric provides two primary ways to execute Spark workloads, notebooks and Spark job definitions. The option you choose depends largely on the type of work you are performing. Let's start with notebooks. Notebooks are the most common way to work with Spark interactively. They are ideal for exploring data, performing analysis, testing transformations, and developing solutions step by step. And a notebook allows you to combine text, images, and executable code into a single interactive document. This makes it easy not only to write code, but also to document your thought process, explain your logic, and collaborate with other team members. Notebooks are made up of individual sections called cells. Each cell can contain either documentation written in Markdown format or executable code written in languages such as PySpark, Spark SQL, Scala, and more. One of the biggest advantages of notebooks is that you can execute code cell by cell and immediately view the results. This interactive experience makes notebooks perfect for learning, experimentation, troubleshooting, and data exploration. While notebooks are great for interactive development, many organizations need to execute Spark workloads automatically. That's where Spark job definitions come in. A Spark job definition allows you to package your Spark logic into a reusable job that can be executed on demand or scheduled to run automatically. This is particularly useful for production data engineering workloads, such as data ingestion pipelines, transformation processes, and recurring batch jobs. When creating a Spark job definition, you specify the script that should run. You can also include reference files such as Python modules containing reusable functions and define the lakehouse that contains the data being processed. This enables organizations to move from development and testing in notebooks to fully automated, production-ready Spark workflows. To summarize, use notebooks when you want an interactive and collaborative development experience. Use Spark job definitions when you need automated, repeatable, and production-ready Spark processing. Both options leverage the same Spark engine, but they are designed for different stages of the analytics life cycle. Now that we understand how Spark code can be executed in Microsoft Fabric, the next step is learning how Spark works with data. And one of the most important concepts in Spark is the data frame. In the next section, we'll explore how to work with data in a Spark data frame and see why it's the foundation of most Spark data processing operations. At its core, Apache Spark uses a low-level data structure called a resilient distributed dataset, or RDD. While it's possible to work directly with RDDs, most Spark developers and data engineers rarely do so today. Instead, the preferred approach is to use Spark DataFrames. A data frame is a structured collection of data organized into rows and columns, similar to a table in a database or a data frame in the popular Pandas library. The key difference is that Spark data frames are optimized for distributed processing, allowing them to efficiently handle massive datasets across multiple nodes. Because of their performance, ease of use, and the integration with Spark SQL, data frames are the foundation of most modern Spark workloads. Let's talk about loading data into a data frame. The first step in any data processing workflow is loading data. In this example, we'll work with a CSV file called product CSV stored in our lakehouse. Actually, I will demonstrate it in our lab section of today's video. Spark makes it easy to read data from files and convert it into a data frame that we can analyze and transform. In a Spark notebook, you could use the following PySpark code to load the file data into a data frame and display the first 10 rows. Here, we have used Python code, and it starts with double percentages PySpark df data frame. So the double percentage PySpark line at the beginning is called a magic. And this tells Spark that the language used in this cell is PySpark. You can select the language you want to use as a default in the toolbar of the notebook interface, and then use a magic to override that choice for a specific cell. For example, here is the equivalent Scala code for the products data example. Double percentage Spark. And it's this magic, double percentage Spark, is used to specify Scala or Scala. Both of these previous codes, samples would produce output like this: product ID, product name, category, and list price. Okay. In the previous example, the first row of the CSV file contained the column names. For example, if we go back, here we can see the column names, right? And Spark was able to infer the data type of each column from the data it contains. You can also specify an explicit schema for the data, which is useful when the column names aren't included in the data file, like this CSV example. For example, here we don't see the column names. And this PySpark example shows how to specify a schema for the data frame to be loaded from a file named product data CSV in this format. From PySpark.sql.types import, multiplication sign, from PySpark.sql.functions import a multiplication sign, product schema, struct type. So we have product ID, integer type, product name, string type, category, string type, and list price, float type. Then data from equals to spark.read.lead and their file location. Schema equals to product schema, header false, and display data from, the first 10 rows. The results would once again be similar to this one. Actually, we saw it a few slides before, right? You can use the methods of DataFrame class to filter, sort, group, or otherwise manipulate the data that it contains. For example, this code uses the selected method to retrieve the product ID and list price from the data frame containing product data in the previous example. The results from that code example would look something like this one. And in common with most data manipulation methods, select method returns a new data frame object. You can chain methods together to perform a series of manipulations that results in a transformed data frame. For example, this example chains, this example code chains that select and where, select, and let's find where, methods to create a new data frame containing the product name and list price columns for products with a category of mountain bikes or road bikes. So let's see results. And the results from that code example would look something like this one. To group and aggregate data, we can use the group by method and aggregate functions. For example, this PySpark code counts the number of products for each product category. df select product ID category group by category count and display counts df data frame. And the result from that code sample would look something like this one. You often want to use Spark to transform raw data and save the results for further analysis or downstream processing. The following code, this code, saves the data frame into a Parquet file in the data lake, replacing any existing file of the same name. The Parquet format is typically preferred for data files that you will use for further analysis or ingestion into an analytical store. Parquet is a very efficient format that is supported by most large-scale data analytical systems. In fact, sometimes your data transformation requirement may simply be to convert data from another format, such as CSV to Parquet. Partitioning is an optimization technique that enables Spark to maximize performance across the worker nodes. More performance gains can be achieved when filtering data in queries by eliminating unnecessary disk I/O. Save a data frame as a partitioned set of files. We use partition by method with writing the data. This example saves the bikes DF data frame, which contains the product data for the mountain bikes and road bikes categories, and partitions the data by category. The folder names generated when partitioning a data frame include the partitioning column name and value in a column equals value format. So the code example creates a folder named bike data that contains the following subfolders, like mountain bikes and road bikes. Each subfolder contains one or more Parquet files with the product data for the appropriate category. You can partition the data by multiple columns, which results in a hierarchy of folders for each partitioning key. For example, you might partition sales order data by year and month, so that the folder hierarchy includes a folder for each year value, which in return contains a subfolder for each month value. When reading partial data into a framework, data frame, you can load data from any folder within the hierarchy by specifying explicit values or wildcards for the partitioned fields. The following example, this example, loads data for products in the road bikes category. To summarize, data frames are the primary way to work with structured data in Spark. We have seen how to load data, infer or define schemas, filter and aggregate information, save results, and optimize storage using partitioning. These capabilities form the foundation of most Spark data engineering and the analytical solutions in Microsoft Fabric. So far, we have been manipulating data using DataFrame APIs and PySpark methods, but Spark also provides another powerful way to work with data, SQL. In the next section, we'll explore how to work with data using Spark, statements, Spark SQL, and see how familiar SQL statements can be used to query and transform data directly within Spark. For data professionals who are more comfortable with SQL, Spark provides a powerful component called Spark SQL. Spark SQL allows us to query and manipulate data using familiar SQL syntax while still benefiting from Spark's distributed processing engine. This makes it easier for data, you know, um, analysts, database developers, and SQL users to work with large-scale data without needing extensive programming knowledge. Okay, so let's start with view. One of the easiest ways to make DataFrame data available for SQL querying is by creating a temporary view. A temporary view acts like a virtual table that references the contents of data frame. Okay, so a view is temporary, meaning that it's automatically deleted at the end of the current session. You can also create tables that are persisted in the catalog or define a database that can be queried using Spark SQL. Tables are metadata structures that store their underlying data in the storage location associated with the catalog. In Microsoft Fabric, data for managed tables is stored in the table storage location shown in your data lake, and any tables created using Spark are listed, there. So you can create an empty table by using the Spark catalog create table method, or you can save a data frame as a table by using its save as table method. Deleting or a managed table also deletes its underlying data. For example, let's say that the following code saves a data frame as a new table products. I will actually demonstrate that code a little bit later. So I would like to go back to give a little bit info also about the Spark catalog, and then I will go on with demonstrating our code. To understand how Spark SQL works, we first need to understand the Spark catalog. The Spark catalog is essentially a metadata repository or metastore that keeps track of database objects such as tables and views. By registering data in the catalog, we can seamlessly switch between data frame operations and SQL queries. That gives us the flexibility to use whichever approach is more suitable for a specific, type or for a specific task. Now, I would like to demonstrate that code. So let me demonstrate that code that we can use for that purpose. Let me find that code. So this is the code, actually, sorry. These are not the code. Actually, whatever demonstrated is the link that we are going to use. Regarding code, actually, it's given here. Let me tell you. Save as table. I mean that one, right? This one. It's written in this part. So additionally, we can also create external tables by using spark.catalog.create external table method. And external tables define metadata in the catalog, but get their underlying data from an external storage location, typically a folder in the file storage area of a lakehouse. Deleting an external table doesn't delete the underlying data. You can use this Spark SQL API in code written in any language to query data in the catalog. For example, this PySpark code uses a SQL query to return data from the products table as a data, frame, right? Okay. And the results from that code would look similar to the following table. The previous example, code example, demonstrated how to use the Spark SQL API to embed SQL expressions in Spark code. In a notebook, you can also use this code, double percentage SQL. This is a magic to run SQL code that queries objects in the catalog, like this one, right? The SQL code example, the previous one, returns a result set that is automatically displayed in the notebook as a table, like this one, right? In this section, we have learned how Spark SQL allows us to work with data using SQL syntax, how to register data frames as temporary views, and how to create both managed and external tables within the Spark catalog. These capabilities make Spark an extremely versatile platform that bridges the gap between traditional SQL-based analytics and large-scale distributed data processing. Once we have loaded, transformed, and analyzed our data, the next step is often to visualize it. After all, charts charts and graphs can help us identify patterns and insights much more quickly than rows of data. Microsoft Fabric notebooks provide built-in visualization capabilities. Whenever you display a data frame or run a SQL query, the results are shown below the code cell, typically in a tabular format with just a few clicks. You can switch from the table view to a chart view and choose different chart types to visually explore your data. So we have built-in notebook charts. These built-in charts are great for quick analysis and data exploration. However, if you need more advanced or highly customized visualization, you can use Python graphics libraries directly within your notebook. Libraries such as Matplotlib and Seaborn allow you to create professional charts and dashboards while keeping everything inside the notebook experience. For example, after aggregating product data, we can use Matplotlib to create a chart directly from our analysis results. So, in summary, Fabric notebooks offer two options for visualizing our data. Quick built-in charts for fast exploration and powerful Python visualization libraries for more advanced reporting and analysis. Now that we have covered the theory behind Spark notebooks, DataFrames, Spark SQL, and visualization, let's put everything into practice. In the next exercise, we'll use a Spark notebook to analyze and visualize data stored in a lakehouse. So let me move my, web browser here. Actually, not this one, sorry. Where I'm just going to enter to my Fabric platform. So I'm already there. Let me cancel it. So I'm going to analyze data with Apache Spark in Fabric. I hope now we have the necessary info, theoretical info about Apache Spark, how to use Apache Spark to analyze data. Now it's a exercise time, lab time. So as we did in every lab, we're going to start with creating a workspace. So I'm going to click on this and say the workspace, and this is going to be Apache Spark. And let's say AWS Workspace, say analyze data with Apache Spark. And then I'm going to select Fabric Trial and say apply. Thus, I'm creating my workspace. I'm inside of my workspace, so-called Apache Spark workspace. And now I'm going to create my lakehouse and say new item and lakehouse. And I'm going to call it like Apache Spark Lakehouse. And I have to be sure that lakehouse schemas are selected. So let's say create. And my lakehouse is going to be created. And now I see tables here and also files. There is nothing. So now I'm going to download, first of all, my data from GitHub. This is the link that I'm going to provide you with, in YouTube chat box, right? And here I'm going to paste. Actually, I have, already downloaded this, file, and I have also extracted that zip folder, and it's located on my desktop, right? And let me open that one. So these are the orders files. So if I go here, this in zip format, I extracted that file, extract all, and here I have my, sales file for 2019, 2020, 2021 years, right? So these are the information. Now the next step is uploading that file into my Lakehouse. So files, ellipsis, and say upload folder. And I'm going to select my folder, which is on my desktop, and say upload, and say upload, and upload. And it's going to be uploaded. Okay. Now everything is uploaded. To be sure, what I can do is I see my orders folder here, but anyway, I'm going to refresh my Lakehouse. Now I'm going to create a notebook. So first of all, we have to find where our notebooks are. So we have to be in our lakehouse. This is our lakehouse. Let me hide all of them. And here I can see, some tabs, right? And the next step is just creating a, notebook. So let's find the notebook. So here, from here, analyze data with, I have my notebooks. I say new notebook, and the new notebook is going to be open. And the notebook one name is automatically is given. If I want to change the name from here, I can click and I can change the, notebook just name. Okay. So, so what we are going to do, so if you pay attention here, I'm just going to convert this line markdown. So, and let's click on edit part. And I'm just going to type, the new names. So let me just, delete. And then what I'm just going to do, I'm going to add one code, and I'm going to copy. And here we can say use this notebook to explore sales order data. And I'm going to call it sales analysis, by the way. Sales analysis. And I'm selecting this one and say Markdown. Yes. So here I can say sales order data exploration. Use this notebook to explore sales order data. As soon as I hover over here, I can see this code and mark down once again. Okay. So we have finished. Okay. So what I'm just going to do, I'm going to create a data frame, right? So let's go back to our uh, lakehouse. This is our lakehouse, and from files, here we have our orders folder, right? And if I select my order, these are my order. So to create a data frame, what I'm just going to do, actually, I'm going to back my notebook. And as I'm here, Apache Lakehouse and Lakehouse, from here, I have my files. Let me select this one. Now I can see this kind of, window. Yeah. So here I have my Lakehouse and my files in folder, and this is my just notebook. Okay. So from here, I'm clicking on ellipsis and saying load data to Spark, right? And I can see the automatically created code on my notebook, right? And let's go just to run this code. I'm going to run this code. It can take a little bit time. And my Spark session started, by the way. And now I hope we are going to see the table that covers 2019, file information. So here, just pay attention to the name of columns, right? So what we are going to do, we are going to make some changes in column headers. So here we are going to have the names of columns. So what I'm just going to do, I'm going to change the line, this line, first line, and it's going to be, it's going to be work perfectly. So what is the next step? So if, we say that actually here it's enough to change this true one. If I'm going to change this to false and say run again, I hope we'll see, something like this, column 0, column 1, something like this, right? But I would like to give meaningful names to my tables so that I'm going to write this code. So here I say code, and I'm going to paste this one. By the way, all the codes can be found in Microsoft Fabric documentation and Microsoft Learn. So if you type, let's say, let me type it here, AKA-MS DP700 Labs, you can see this kind of stuff, right? And we are now demonstrating this one. So here we have all the, necessary codes. So from here, you can just, practice these codes. Okay. Okay. Now let's run this one. And I hope we are going to see something different. Okay. So let's wait when it finishes. Okay. Good. Now we have very meaningful, uh, column names, right? And it's every columns data types is also defined. Okay, good. So the next step, is just to pay attention that we have only displayed 2019's, year sales data here. So I'm going to make some modification in the code. Actually, what I'm just going to do, I'm going to, just um, I would like to add all the files from this folder. So just pay attention here. Our code line uses this multiplication sign. So it will help us to, you know, um, extract all the files from the folder. So I'm going to uh, just copy my file. I'm in code. And here I'm going to paste it. Control V. Just pay attention. Instead of 2019, if we are going to here, let's see, here we have, 2019. Instead of 2019, here I'm going to add only this multiplication sign. And it means that it will help me if I go to run, it will help me to extract all data. Now we will see all the data, not only for 2019 year, but also, 2021 and so on and so forth. These are, we just wanted to, display. Okay, now let's explore data in a data frame. So what I'm just going to do, I'm going to add one more line code, and I'm going to paste this one, which is going to create a data frame for customers. And I'm interested in number of customers. So let's run this and let's see what I'm going to just get. So yeah, here, uh, say what it gives us. Let's say this code, first of all, creates a data frame called customers, which contains a subset of columns from the original data frame. And so, and we get at the end of the day this unique list of customers with their, email addresses, right? Okay. Actually, we can also, use this code. It's very simple, just to get the necessary displays that we got a little bit earlier. So let me select this one and delete, and let me, run it once again. Okay. Yes. Customers. Okay. So I'm going to delete also this one. This is enough for us for now. So I can use here, select, method to make, and also I can use here where, method together to make some modification in my code to display my output in a little bit different ways. For example, let's copy the following code, and here I'm going to add this code. For example, here I'm going to display the customers with their email addresses, who the customer that bought this item, right? So let's run this one. And this is what I'm going to get, right? And now I'm going to aggregate and group data in a data frame. So let's go down. And here I'm going to paste this code. So let's run. And here, just pay attention. We have, our let's say, products have been grouped by their sold quantities, right? So you can use that code just to display this output. So I'm going to use another code. Let me add it here and say run. And this gives us a little bit different, you know, output like year and count of, say, orders, right? Orders number by year. So here we have used, PySpark SQL functions. So once again, this output is giving us the necessary information, the number of sales orders per year. Here we have import statement that enables Spark SQL library. We used a select method that enables us to use the Spark SQL library, actually SQL year function to extract the year component of the order date field, and group by methods. This one helps us to group the data by the derived year column. Now, we are going to use Spark to transform data files. For this purpose, I'm going to use the following code. So here, every line's explanation actually is given, right? For example, and at the end of the day, after running this code, and the month column added based on the order date column. First name and last name columns will be added based on the customer name column, and the columns are filtered, will be reordered. So let's run it and let's see what kind of outputs we are going to get. Just pay attention here. This is what we are just going to, get. This is something like transformation. Now, what we can do, we can save our transformed data. So for this purpose, I'm just going to add one more code, Control V. Just pay attention, transform data frame, write mode, and say enter. And this is going to be saved. So I can refresh, my Lakehouse. While I'm in Lakehouse, I can refresh it. I will do it a little bit later. Then I'm going to just add one more copy. One more code, and I'm going to run it. Here, thanking to the last code, a new data frame will be created from the Parquet files, from the transformed data orders folder. So to see all this, I'm going to back just my Apache Spark Lakehouse. And here I'm going to refresh everything. Okay, and you see here I see this file, transformed just data. That was we created thanking the last file. So I'm going to back my sales analysis, sales analysis, say, notebook. Here also, I can refresh also. Yes. So, what I'm just going to do, I'm going to add one more code that is going to be related to partitioning. So this is my code. I'm going to run it. And now I don't see it here. If I go to my lakehouse, actually, yes, it has already been done. My lakehouse, and here I'm going to refresh. I see my partitioned, data. Okay, just now we have seen the native methods of the data frame object that enables us to query and analyze data from a file. So we may be comfortable with using some SQL syntax, and Fabric Lakehouse support delta tables, which are stored in one lake and can be queried using Spark, SQL. So I'm going to use SQL language, SQL, just to query my data sets. I'm going to back to my sales analysis notebook, and here I'm going to select code, and let me, paste my code. Just pay attention, and I'm going to run it. So this is what I'm just going to get if, yeah, it's running still. I will go to my lakehouse back. You see, I'm getting these, results. I mean, output. So I can, just let me refresh it also here. Say refresh. Can also refresh it here. And if I go back to my lakehouse, yes. So I can refresh my, files. And here I can see, the result like this. So which means partitioning, right? Okay, so what else I'm just going to do? Um, so actually, let's go to our lakehouse back. This is our lakehouse. So I can see our sales orders that created tracking the last code. So here I can click on ellipsis, and what I can do, I can, just actually click on here. Let me, yeah, let me select it. And here I can just load that data to, Spark. So let's click, and yes, actually we have done it. So let me do it once again. So what else we can do? Just we can write um, one more code that, let me go back to our sales analytics notebook code and say Control V and run my new, yeah, I think it's not correct. So after partitioning our data, we can write some other different codes just to make the necessary transformation in our data set, or just to query our data set. So just using different languages, including PySpark or Scala or R language or SQL. But so this is what we can do with Spark. So here I would like to, end our today's session because it took a lot of time with practical part of the session. I hope in next session I will go on with this lab where I will be demonstrating visualizing data with Spark and running some SQL code in this environment. So let me go back to my um, presentation. So thank you very much for joining me today. Once again, it took a little bit more time. So I would like to summarize what I did today. I just talked about the fundamentals of Spark, including Spark pools, runtimes, environments, data frames, Spark SQL, and data visual. Actually, I have not talked about data visualization that I'm going to talk about in next session. Thank you so much for taking the time to watch this video. My next session is going to be on August 8th, 2026. In that session, I will demonstrate how to apply the other features of Spark, demonstrating one lab. So thank you very much. See you in next session.